Hey guys, welcome back to LeetCode problem solving series. And today we are trying to do a bit different and trying to solve a question related to linked list. Uh, I have been studying about linked list for a few days, and I have studied how to add, insert node at starting and at end, and how to uh, in both single linked list as well as in double linked list. So let's try to solve question. And the question we are trying to solve today is remove duplicates from sorted list. Uh, Actually, before recording this video, I looked at this question and I found it a bit difficult. So we won't be solving this question today, and we'll skip this question and go to the question number 83, whose title is remove duplicate from sorted list. And the question description goes as given the head of the sorted linked list, delete all duplicates such that each element appears only once. Return the linked list sorted as well. So we have to return the head pointer after uh, doing what we have to do. And these are some example. And the constraint is number of node in the list range from 0 to 300. Node value, the list is guaranteed to be sorted in ascending order. Okay. The topic related to the question is linked list only. So if we have basic concept of linked list, then we will be able to solve this question. So the question is telling us that it will give us a list which will be stored on the basis of linked list I using pointers, and the elements will be in ascending order. The list is or sorry, the question has given us the head pointer, and the node structure is given as it has given us integer member for storing value, a pointer for storing or pointing towards next node, uh, and these are some constructors with their own condition. We don't have to think about this as we are not creating any new node inside of here. We are simply checking the value of the nodes and deleting the duplicate nodes and also rearranging the pointer. That's what we are going to do. So let's try to visualize our problem. Then we'll try to write it algorithm. It's algorithm. Okay, so see, let's see what's given. 1 1 2 3 3. Okay, 1 1 2 3 and 3. Okay, so we have to remove the duplicate element. Uh, we already know the basic concept of linked list. For those who don't know about linked list, I'll try to explain it in simple words. There are various type of linked list, but we will only discuss about single linked list today. In linked list, we use on node, which has two parts, one for storing value and one for storing pointer. And this is the upgraded version of array. Basically, in programming, we can store list in two ways. First of all, we can use array, and in another way, we can use linked list. If we are using array, then if we have to remove a particular element or sort the whole linked list, then it becomes, sorry, not linked list, the array, then it becomes a bit difficult as we have to go through each element, meanwhile also rearranging them, so the position will need to be swapped, which becomes difficult. But in linked list, these elements are not located continuously. As in array, each element is located in continuous memory block, whereas in case of linked list, they are not located continuously. They are simply pointing towards each other. Uh, in simple linked list, we consist of a head pointer which always point towards the address or the memory block where the first node is present, and the first node value will have value, whereas the pointer will point towards next pointer. So the question is telling us to return the head node after sorry, not the node. return the head pointer after we have erased all of the duplicate element. As we can see, one is duplicate here and three is duplicate here. We have to also consider about one condition where if we are in last condition, then it is pointing towards null. If the node is last, then it will always point towards null, which we have to consider. Okay, so what we can do is we can use while loop to go through each node and check whether the node is equals to the value, the node current node value is equals to the next node value. If they are equal, then what we can do is we can remove the next node completely and use the pointer of current node to point towards the value which is present next uh, one step ahead node, which we can do by doing. Suppose if temp is used for storing our current node, then what we can do is we can use temp next, which is the pointer, and we can use it for storing value present inside of temp next, as temp next represent the pointer, but if we use temp next, then it is uh, intending to say that uh, the the address which is stored inside of temp next node will be stored inside of a temp next member variable, which we can use for is simply skipping and pointing towards this node. And after that, what we can do is we can erase this node by using delete operator. And after that, we can go in this node and we can compare this node with this node. Okay, let's try to cool. What we can do is we can simply, sorry, as the structure name is list node. Okay, list node temp equals to it. So we have the address of head in temp. We are not directly accessing the pointer through head as we require head uh, uh, for returning the answer or returning the pointer pointing towards the first node, which should always remain same. So we won't ever change it unless we are removing the first node or adding a new first node. So what we have to do is after creating a head, what we can do is while temp is not equals to, okay, instead of doing this, what we can do is while temp next is not equals to null, as we will be comparing temp with temp value with temp next value. So if temp next value is null, then it won't uh, do us any good. Before doing this, what we should do is the uh, list can contain zero elements. So first of all, what we have to do is if head node equals to null, which means that if the value or sorry, if the linked list doesn't contain any value, then simply return the head without doing anything, right? And we can also see if temp next not equals to null. So uh, if a linked list only consists of if a linked list only consists of a single node, then this node will always be pointing towards null. So what we are doing is if temp, which is currently pointing towards this null, sorry, this node, and we are using temp next. So we are accessing the value present inside of this next member variable or member pointer, which value is null, and we are using condition not equals to null. So what will happen is the condition will become false, and uh, it will return here. Okay. So what we have to do is uh, until temp next doesn't become null, we have to. compare if temp value equals to next value. If these value are equal, then what we have to do is temp, let's see, if this value is equals to this value, if these value are same, then we have to first create a uh, instead of creating it here, what we can do is we can create it here in order to save memory. List node to delete. To delete equals to. Let's initialize it to null. First, what we can do is if uh, these two are same, then what we can do is we can use to delete pointer to point towards same next, which will point to this one. Right now, what we can do is, as our pointer is safely secured, we can change the value of temp next. Temp next equals to temp next. So after doing this, the temp next current temp next, this pointer will point towards this node. So now we can safely delete to delete. So if we delete this, then this one should be deleted. Yeah, this should be deleted. So after deleting this, our current position should be this. Yeah. So now, after doing this, uh, what we have to do is temp equals to temp next is we can see temp is now pointing here. So uh, uh, we are currently temp is pointing here, right? But temp next is pointing here, and we are assigning temp to temp next. So now temp will point. Now temp will point here, and again the condition will go, or the loop will iterate in next iteration. Is the executable code present inside of the scope of the loop has ended, and we are here now. And again, we are checking the value present inside of temp to the value present inside of temp next. Is these value are not equal, so we don't have to delete a node. And so this if block will be not executed, won't be executed, and will come here in line number 25. And uh, again, the temp will now point here without changing anything. Yeah, and now again next iteration will go, and now we are checking temp next is not equals to null. Is temp next is pointing towards 3, so it is not null. So we are comparing these two value again. As temp value is equals to temp next value, so we'll come here and we'll secure the to delete pointer, or the pointer which we need to delete, which is this. So to delete will store. To delete will now store. Now to delete will store the address of this node. After storing the address, what we can do is we can use temp next to we can set the temp next, which the temp is here, so the temp next will be assigned to temp next, which is null. As we know, the last node always point towards null, and we know after removing this node, this current temp node will be the last node. So it makes sense, and we delete the node or the node duplicate node. After deleting, uh, after deleting the node, our result value will be 1, 2, 3, and yeah, 1, 2, 3, which is correct. 1, 2, 3. Temp next, return add. Okay, let's run the code and let's hope the answer will be correct. Runtime error, member access with null pointer type list node. So we have assigned temp to add, and we are checking if add is equals to null, then return, right? And why is saying we are accessing null pointer? If the pointer was null, then it should it, I know this won't solve the problem, but it is better to put temp here as assigning temp equals to add. Okay, so this error only occurs when we are accessing a null pointer, right? But as we can see, uh, temp is not null. Okay, because if temp was null, then the function should already be returned, or its execution should always already be stopped. Let's let us copy this error and feed it to ChatGPT. Let's see what it will say. That you are trying to access a member of list node object, but the pointer of that object is not returned. Yeah, I know that. Save for null pointer. Okay, what we can do is we can add 10 is not equals to null. As in this case too, we are returning it. So instead of doing this, what we can do is we can use 10 not equals to null and do this. Hmm, okay, so let's do that then. But I was checking the condition, right? I was checking temp equals to null. If it is null, then return. If it was not null, then execute the code after the if condition. So if it is executing the code after the if condition, then the pointer shouldn't be null. If temp is not equals to null, then execute this code. Mm, okay, so I mistakenly put the parenthesis. Yeah, let's try to run this thing. Now we are checking. Okay, so I accidentally rewrote NUL. So if it is not null, then it will only come here. Member access within null pointer of list node solution. Let's see if there is an issue. We won't look at the solution, we'll only look at the issue. The issue in your code arises when you attempt to delete the node to delete and then continue to advancing them after modifying. Okay, I guess I got. I'm deleting temp next. Yeah, I'm deleting temp next. But the issue in your code arises when you attempt to delete the node to delete and then continue advancing. Okay, okay, so I got it. We are deleting to delete. And again, we are to delete is already deleted, and instead of redeclaring it, uh, trying to trying to use it without it existing. One issue is there, but that's not our main issue. Our main issue is coming in team. Yeah, that was not this. If you delete a duplicate node, you should not advance temp because the node after the deleted node is now the next candidate to check. Okay, so what it is saying is if we are deleting this node, then need to check this node with this node again. So we shouldn't advance the node. Okay, in that case, we can use break. Yeah, we can do that. Temp is not equals to null pointer and temp next not equals to null pointer. If so, what happens if we instead of using null we use a null pointer, then will it work? A null pointer, yeah. Yeah. What's the difference between null and null pointer? Null means absence of value. Okay, so it worked, but the answer didn't give. You can see our output consists of 2, 3. It shouldn't be okay. Right. So let's say instead of using break, what happens if we don't use the break? Okay, so if we don't use the break, then this issue arises. However, if we use the break, then this issue don't arise. Okay, so let's see. So let's visualize it again. Uh, one, one, two, three, and three. Right? So the one was deleted. So it worked for first scenario. Let's suppose let us suppose we are at this part. So our t is equals to 3. Okay, so let's go through first index. It will be easier to understand if we do that. Let's suppose the temp is pointing towards 1. Now we are comparing temp value with temp next value as they are equal. So what we are doing is we are using to delete to point here, and uh, we are linking this node with this node, right? And after doing that, we are erasing this node. After erasing this node, after erasing this node, we are again after erasing this node, the loop breaks, and we are now here. Right? Now we are comparing temp value with temp next value, which is this. As they are not equal, so we are advancing temp by one. So now temp is here. Now temp is here. Now we are comparing uh, the temp with temp value with temp next value, which is not equal. So now temp is here. Okay, so now temp is here. Now we are comparing this value and this value. Okay, so now we are comparing this value with this value. Sorry. And as we can see, the while loop condition is temp next is not equals to null pointer. As you can see, the temp next is pointing towards this three, so it is not a null pointer. So we're comparing temp value with temp next value, which is this value. So what we are doing is we are using to delete to store the address of this tree. Then what we are doing is we are using temp next. We are using temp next to store temp next which is null for null pointer. Here it's null. Yeah, null pointer. And after that we delete this. After that we are deleting this node. Okay, so it should work. Then why it's not working? Why is 3 coming here? Okay, it is also this it is also this creating node to delete and storing temp next and temp next is storing temp next. After that we are deleting to delete. I'm using break. It is using else. It's the same thing as we are skipping the loop here. In that case, it will come here as else block won't be executed and the executable part has ended. It will come to next iteration. If no deletion occurred, yeah. And in our case also, if deletion don't occur, then it will come here. The condition is while temp is not equals to null pointer, but if temp next is on null pointer, then I will temp be null pointer. Okay, so let's just add while temp is not equals to null pointer, then let's run this again. Yeah, the code is same, right? Returning it. Yeah, I'm returning it too. Yeah, the code is same. Let's copy this. The code is exactly same, so the result should be same too. Let's run this and check. Will it work? Oh, it worked now. Wow. We were doing the same thing, right? Let's compare this block by block and see. Okay, let's compare. Mm, we are creating a template. That's correct. I'm using if temp is not equals to null pointer. Okay, the condition is same. So even if we don't use it here, it doesn't matter. And if temp next temp value equals to temp next value, then list node to delete equals to temp next temp next equals to temp next delete to delete is break the problem, yeah? Let's try else, let this, now let's run this. Okay, so if else was the problem. Okay, so let's submit it. Okay, so that's the answer. My answer was being incorrect because instead of putting else, I was putting break. So if I put break here, then okay, I am sort of fool. Instead of putting continue, I was putting break. That was my mistake. So if we have put continue here, then the answer should be same, right? I was trying to skip only a single iteration, but I forgot that break completely exits the loop. Yeah, that's my bad. Yeah, I was the fool here. So the memory efficiency is only 26.37. Can we improve it? We actually could improve it, but I think if we uh, use to delete, then will the pointer get deleted too? Let's ask ChatGPT for the solution. Yeah, just ask if we use delete, we delete, then we will only allocate memory get deleted or the pointer to delete also will get deleted. Okay. I put this really mistake here. When you use delete operator in C++, the delete to delete only the memory that the pointer. Okay, so instead of reinitializing it again and again, what we can do is we can simply list this node uh, to delete equals to null ptr. Let's run this first before submitting to check whether the answer will be correct or not. Now let's submit it and see whether the memory utilization will be, yeah, it improved. However, it is not 100%. Why is it not 100%? I'm only using a single temp block and to delete block, which is bare minimum, right? Yeah, it is big of n. This is also big of n. This is big of 1, this is big of n. Okay, so that's it for today. Thank you for watching. Uh, Today is the first day we have solved first linked list question. From now onwards, we will try to solve different type of question. Okay, so uh, let's look at the. I'm currently, okay, so I mistakenly clicked design in architecture instead of DSA. Currently, we are uh, currently we are learning linked list, right? After finishing linked list, we learn stack, queue, and as tables while solving their problem. After that, we'll move towards data structure. Sorry, not data structure, towards algorithm complexity, which is important to learn, and then we will learn different sorting algorithm, then sorting algorithm. We are already using linear sorts. What we have to learn is this binary tree, as we have skipped a question related to binary tree previously. Okay, we are already using sliding window technique, two pointer technique. We already know two pointer technique and sliding window technique. We know recursion, we also know brute force. I know a bit about divide and conquer algorithm, sorry, divide and conquer problem solving technique as it is used for um, this merge sorting, right? Okay, so I hope we'll be able to be half as good as what you are at DSA in a year. Okay, now that's it for today. I'll try to learn. Okay, I am trying to set a goal for me for tomorrow. Linked list. Okay, gigs for gigs. I have already learned about double linked list. I have learned about linked list insertion, sorts in a linked list. Length of a linked list we can simply uh, add. We can do that. Creating a given key, we can do that. Deleting a given position, we can do that. Deleting a linked list, whole linked list. Okay, that is possible. Add node from start. Okay, so I think we can do this. Uh, 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 try uh, LeetCode problem, try to solve the problem. But tomorrow I'll try to learn about short learning target for tomorrow. Okay, thank you for watching. I'll see you tomorrow. Bye.